We're nearly there now with displaying our real database tasks in the app. We've actually done all of the hard work. We've got our database, our task data access object, our task DAO. We've got all the recycler view code done, the layout and the adapter, and we understand about threads and updating the UI from the run on UI thread. So we have everything we need to quickly change our fake tasks here with the real ones. So we're going to need access to our task DAO. Now in the main activity, we had two class properties, a database latent property and the task DAO, which was a lazy property. We probably don't need both here, just the task DAO will be enough. And again, we'll make that a lazy property. So we can do private val, our task DAO of type task DAO, and we'll do by lazy. And then I'll make a line break for this lazy block. So we can actually get the database variable and then get the task DAO all in one go. So we could do get it done database dot create database. And we do need some context. So we'll do require context, which is a function that gets us a non-null context. Remember, the fragment is attached to a context, which is our activity, but the fragment itself isn't a context. It's always a little bit of a pain when you need context inside a fragment, but it's just one of those things that we have to do. So require context. We're getting an error because we're expecting to fundamentally return a task DAO here. So we could either make a local variable called database and then do database.taskDAO, get task DAO rather, and the lazy block will return the last line, whatever it is. We don't need to say the word return, okay? Or we could just call get task DAO on that line itself. So we could actually just do that as well. Doesn't really matter. Now it is worth noticing that we call the create database function in main activity as well. Okay. Now, fortunately for us, if I just click into the create database function, this Room database builder, it will recognize that it's already been built and it will return just the simple get it done database underscore impler class, that same code that we need. It won't create any more database files or overwrite the file or anything like that. So there's no major problem in terms of calling this function twice. However, very shortly, we are going to look into some of the potential pitfalls about having multiple versions of our database variable like this, okay? And we'll look at the first approach we can do to not have duplicate versions of our database file, which can be problematic. We'll come back to that concept. This is going to be fine for now, okay? Don't worry that it looks like we're creating the database twice. Technically, we're not, and we will look to improve the create database function shortly. So we have a task now. So now in the onView created, if I make some line breaks above the adapter, we can now call a task DAO database operation. And for that, we need a thread. So we'll do thread, and we can get our list of tasks simply with taskDAO.getAllTasks. And now we have our tasks. So you might think we could just cut this line and paste it into here, and then replace our tasks with the real tasks. I'll just put that on one line now. But can you think what the problem with this will be? The problem is this is updating the UI, updating the display, and we are only allowed to do that on the main thread, the UI thread. So then you might think, okay, I'll start typing run on UI thread, and you might be disappointed to see we don't have access to it, and that's because it's part of the activity class. Okay, it's not available to us in fragments, it's part of the parent activity. So the way we can access that useful function, the run on UI thread function, is with require activity, similar to require context, dot, and then we can do run on UI thread. And we'll do the one with the curly brackets. So now we can cut this line, paste it into here, okay, remove the line breaks, there, there, and there, and that should be all we need to do. We've done all the hard work with our task DAO. We know about threading. We know about running things on the UI thread. And we already know that our tasks adapter works. So what do we expect? Well, when we run this app in just a moment, we should be seeing all of the tasks we have inside our database. And brace yourselves, there could be quite a few, some junk ones we did. We will be working on the functionality to delete tasks within the app in the coming tutorials, so that's not a problem. But with the small amount of code done, let's go ahead now and run this. Okay, and there is a long list of junk tasks. Quite a few there without a description. Some task, another task, another task. Okay, and it's a recycler view, so it scrolls nicely. And later on we can see we started to add some with descriptions. So my cool title, some funky description. The last task we added was hello, how are you? So you might think, okay, I'll add a new task. So my very latest task, and then press save. However, we don't see our updated task there. So that's a to-do in the future to refresh the tasks when we add new ones. Of course, if I clear the app out of memory and then open it again, well, then I do see my very latest task. So we are making strong progress now with actually using the database for our app's functionality, which is fantastic. Just jumping back to the code before I finish this tutorial, I mentioned how it could be slightly problematic having two versions of this get it done database file living in our app at the same time. Just jumping back to task fragment, if I shift into main activity and scroll to the top, we also have the get it done database here, and we're calling get it done database.createDatabase on line 37 for me in main activity. So in the next tutorial, we'll seek to understand the different ways that that could be problematic before moving on to a common solution to the problem of having multiple database properties living in our app. And this very common solution to that is a design pattern called the singleton. So let's look at that in the next tutorial. Our next tutorial is on the programming concept of the singleton, which is a design pattern. Thinking to our project, we discussed some of the issues around multiple versions of our database. Indeed, multiple database instances cause conflicts and resource wastage. Addressing the resource wastage first of all. Do we really want that room database builder code to be happening every single time we want to access our database? That room database builder.build function, really that should be a one-time thing. We don't need to be building it over and over again. That's a waste of code, a waste of memory. It doesn't give us anything. And then, as we've already mentioned, we could potentially end up with multiple instances of our database spread throughout our app in main activity, in a tasks fragment. And imagine now we have a thread launched in the main activity to add a task, which those database objects, and then at the same time displaying our tasks from another database instance. And as these are all running on different threads, without necessarily having any knowledge of each other, you could, in theory, have perhaps an update operation on a task that has at the exact same time just been deleted. So it's really not a good idea to be having multiple instances of our database. And this problem exists throughout programming, the need to have just one single instance of something, for the same reasons, to avoid conflicts, to avoid wasting resources, okay? So what is a singleton? A singleton's purpose is to ensure only one instance and global access. So its purpose is twofold. Yes, we want to enforce that one and only one version of it exists, but the global access part is also important. This access to this singleton, it should be readily available globally throughout the app. There shouldn't be multiple ways to get at it. There should be one single way to get at it, and when you request it, it is the one and only instance of it, and that's what a singleton is. If we take, for example, this bit of clip art that I found online that represents the singleton, there may be many parts of our app with a need to communicate to our database, but through our code, we ensure there is just one and only one version of it, the singleton, and it is globally accessible. It is easy to get to from anywhere within our app. Now, it is worth mentioning in the programming community, some feel that singletons can be problematic. However, some of the reasons for which it can be problematic are potentially more advanced than where we are at the moment in our programming journey. If I just continue, usually they're relating to things like global properties in general being a bad idea, and there's whole threads of discussion on the idea of not using global properties. There's issues around testability, if you're trying to test some code that depends on this fixed single thing. And there's other ideas about code coupling. Anyone that accesses this singleton, well, that code is tightly coupled to that code, meaning it's really important that the singleton doesn't change, as it could break things. So pushback against global properties, testability, code coupling, some of these concepts are a bit beyond where we are at the moment, so we don't need to worry too much at this stage. And it is important to note that later in the course we will be moving towards better practices. And pretty much most of these things that you see here, testability, code coupling, singletons not being the best idea, most of these things are solved when we start to learn about architectures in programming, which we will be doing, okay? I just thought it would be worth mentioning, even though we're going to use the singleton design pattern now, if you read some things online that suggest it's not the best approach, and for me there are valid use cases for using it, it's just another tool in our toolbox, so this is a point of debate. But regardless, we will be developing and maturing our approach as we go through this course, okay? But for now, it's going to be absolutely fine. For those of you wondering what the specific better approach to a singleton would be, well, here's a little spoiler. Dependency injection, a very, very fancy sounding term for a very simple concept. That may be a better choice, and indeed is one that we will be covering when we move on to architectures later in this course, okay? So for now, let's make our database a singleton. I'm back in Android Studio, and the only file that we need open for the rest of this tutorial is the getItDone database. So at the moment, whenever we call create database, we're returning a new room.databasebuilder.build, which is a waste of resources and could lead to conflicts as there would be multiple versions of the getItDone database living in memory. So if I just do a comment underneath this, we sort of need to say, if we don't have a database, make one, else return the existing one. We need to write some code that essentially says that. And there's a couple of extra fancy words we need to throw in to manage the fact that this could be launched from one of many threads. So we need to make this what's called thread safe with a couple of keywords, very strange sounding keywords. I will explain them, and they're not words you'll typically see very often, so we don't need to go into too much detail. So the first thing I'm going to do within the companion object is make a kind of constant. We'll make it private for reasons you'll see in a moment. So a private variable, something that we can set and update later, and we'll put this in capital letters as we're inside a companion object, so this will be a kind of constant. So private variable, and we'll call this our database instance of type getItDone database, but we'll make it nullable, and initially it will default to null. And if I make some line breaks above the return block now to try our new approach, so we want to say if the database instance is not null, and then some curly braces. So if it's not null, then we want to return it. I'll just do a couple of exclamation marks to assert it not being null, although we will improve this in just a moment. That's not the best way. So if it's not null, return it. Else, well then we want to create it. So what we'll do is we'll make a local variable called the instance. Then we will assign our database instance to this new instance, but then we'll simply return the local variable, okay, and return the instance. So if the database instance that we have here is not null, then return it. Else, then we can run the room database code, build it, assign our database instance constant above to this local instance, but then just return the instance directly. So we can delete all of this code now. So this is not a bad start, but we do need to make it thread safe. But before we do that, let me show you a cleaner way of doing this code. Saying if something is not null, return it, else, and then doing the else block. There's a very fancy thing in Kotlin called the Elvis operator. It's such a tiny, simple little thing that it's not really worth an entire own tutorial, but it's a very cool thing. We can say, return database instance, And that's an error because that could be null. Okay? So then we can do a question mark after a bit of space. So space, question mark, a bit like our safe calls. And then we can do a colon. And that's called the Elvis operator, because if you turn your head to the left, it kind of looks like a pair of eyes with a quiff. Okay, so that strange question mark colon symbol is known as the Elvis operator. And what that's saying is, if it's not null, return the thing on the left. Otherwise, return the thing on the right. So then you might think, how can I run all of this code block after this? Well, you could type the word run and do it that way. And then we could put all of this code into there. That's fine. So the word run, meaning running that code block. But we actually need to make this thread safe. And what that means is we want to prevent the Android system from having the same code running twice on two different threads. So I'm going to introduce you a very strange term, one that you only really see in relation to threading, and that term is synchronized. So rather than run, we do synchronized. And we have to say the word this, synchronized lock this, and this is relating to threading. And in very, very simple terms, what this synchronized block is saying is, do not allow this same block of code here to run on multiple threads. Only ever run it on one thread at a time. And the fantastic thing with that is, it basically guarantees our room.database builder will only ever run once. As let's say 3 or 4 threads try to call create database. Well, synchronized prevents them running at the same time in parallel. So this will run once on one thread. And then by the time the second thread gets to it, well, because of this line, database instance will no longer be null. And so it will just return our instance. And we actually don't need the return statement there. We can delete that. The return is implicit. Okay. So this is a very strange looking bit of code, but this is a way that you would create a singleton, especially one that is thread safe in Kotlin. We have a nullable constant in the companion object. Return the database instance if it's not null. Then we have the Elvis operator. Turn your head left and you'll see what I mean. If it's not null, return the left. If it is null, return the right. And we can do a thread safe code block using the word synchronized this, and then we can put our code to return the new instance. The final thing we should do to be ultra thread safe is another strange keyword. We annotate the constant with @volatile. And without having a big deep dive into what that means, again, in very simple terms, that means no matter what thread is running this code, don't store this variable in any sort of thread cache, any sort of CPU thread process, which can happen. I want you to store this centrally in main memory. So when you have any kind of variable or constant that could be running on a thread, and therefore it could be part of that thread's cache, that thread's memory, by doing @volatile, you're saying this is a very important property. It could be accessed from multiple places, so I want you to put it on the main memory, not in a thread cache. Okay? So volatile, strange word that guarantees that our constant is in the main memory, therefore only ever in one place, and then synchronized, ensuring that this code only ever runs on one thread at a time. So we should probably rename this function. Rather than create database, we can now call it get database, because if it doesn't exist, it will be created, but if it does exist, we are simply getting it. Okay, phew, a fair chunk of strange code there just to make a singleton, and later on when we move to architecture and dependency injection, we will eventually be deleting all of this in favor of a more modern approach. But congratulations, we now are guaranteeing only ever one version of the database in our app, which is fantastic. Okay, let's move on. We've a few to-dos to get our basic functionality working well. One small to-do is, I've just scrolled down to the very bottom of my tasks. I can see that my last task added is one that says, my very latest task. However, if I add a new task with the add task dialog, adding another task, and then save, well, scrolling down, this new task hasn't been added to the bottom of the task list. So we do need some method to refresh the tasks. Now, in a later section, we will look to develop the Get It Done project with an architecture, MVVM, and something called Kotlin Flow, which is a super cool thing in Kotlin where data can receive updates automatically, and you can just observe those changes. So later on, we will have the absolute best practice way that whenever anything changes in the tasks table, this list will update automatically. However, with where we are in our learning at the moment, we just need some manual refresh. So I'm inside the main activity, and at the very bottom, there is the page adapter where we return the tasks fragment. If I just jump into the tasks fragment, I could quite happily extract all of the code in onViewCreated to a method that says fetch all tasks. Now by default extracting that makes it private, but if I remove the private access modifier and then head back to main activity, well, here where I create the tasks fragment, I can now call dot fetch all tasks. There is modifier and then head back to main activity. Well, here where I create the tasks fragment, I can now call dot fetch all tasks. There are more sophisticated ways to communicate between activities and fragments, such as through interfaces or shared view models later on when we look at architecture. But at a basic level, it is acceptable for an activity to call a function on a fragment that it contains. So to fix this, rather than returning a new tasks fragment object here, we will instead create a class property. So we'll be holding onto this in memory. But as we only have one fragment at the moment, that's going to be okay. So private val, our tasks fragment of type tasks fragment, and we'll go ahead and instantiate it right here, as until it gets attached in that pager adapter, it's just going to be an object. It won't be attached to anything. So we have our tasks fragment now as a class property. So I can scroll down and in the pager adapter just return the tasks fragment like that. And then in our show add task dialog, the class property, so I can scroll down and in the pager adapter just return the tasks fragment like that. And then in our show add task dialog, when we save the new task, well, just after calling dialog.dismiss, we can go ahead and now call task fragment.fetch all tasks again. And that will launch a new thread, fetch all the tasks, and then set a new recycler adapter in this function here. Okay? Now, for those of you who have had a sneak peek of architecture in Android, like MVVM, please don't be disheartened about this. It's not best practice to be holding on to fragments like this, really, for memory, although in our case it really won't matter. Typically, when you have a good architecture, and each part of your app is self-contained and has everything that it needs to take care of itself, you don't really need to do this idea of calling methods on fragments. But for us, it's going to be far preferable than setting a new pager adapter, refreshing the whole view pager and the task fragment from scratch. That'll be far more expensive, far more wasteful in terms of resources. So when they save a record, we call the fetch all tasks function again. So let's go ahead and run this and make sure this works. I see now I have adding another task at the bottom, and when I click the add button, the very latest, exclamation mark, exclamation mark, exclamation mark, and then save. Well, now when I scroll down, I have the very latest there. So that does now refresh the list when we add new records. So that's one of the problems with our functionality fixed. Let's move on.